For this industrial robotics experience, you're going to start by going over to the sim building, and you need to go find room sim 190, which is this automation studio. The folks over in the sim building have set up a couple of these training boards to teach students all about how to program PLCs. So go over to these boards here and take a quick look around at the parts that are up on the board. And I'm going to start today by giving you a brief walkthrough of what each of these parts is. This board contains a complete setup of parts to introduce you to industrial automation. To start with, take a look at this box over on the right hand side of the board near the bottom. Each of the parts on this board is the industrial version of different kinds of parts that we've used in lab before to do our mostly embedded robotics. In general, the kinds of parts that we use in our labs are the parts that you would use to make robots that are mobile. In order to make mobile robots, you need to run on lower voltages and use small currents so that the batteries that you use to run your robotic devices will last sufficiently long. But in some cases, you would like to be building robots that will not be mobile. They won't be driving or flying or swimming or being worn by someone. These robots would be perhaps located in a factory and attached to the ground, and they can be connected to a power source at all times. Now you know that with the parts that we use in lab, in the case where we want to use a part that runs on a higher voltage or uses a higher current, we have to use some kind of external part like an H-bridge or a transistor or a relay or something like that to prevent the higher voltages and currents from going through our microcontroller. Now, in the case where your entire system is connected to power and all of the parts you're going to be using run on higher voltages or currents, it makes sense to use a kind of controller that can handle these higher voltages and currents. And the most common type of controller that can do this is called a PLC. And that's what you see here in this box. PLC stands for Programmable Logic Controller, and it's the industrial version of a microcontroller like a PSOC. In fact, if you look closely at this PLC, you will see that some of these boxes are labeled for what they are. This first box is the CPU. This is the part that will be doing all of the computing. And then if you look at these other boxes here, some of them are labeled as inputs and some of them are labeled as outputs. These are like the pins on your microcontroller. You can connect input and output devices to your PLC. Now, if we look at other parts on the board, you'll see over here we have some push buttons. These would be digital inputs. And you'll also notice that each of these has a label next to it. We'll be using that later. These things over here are LEDs, so they are outputs. You'll notice that the labels by the LEDs, which are outputs, start with an O. The O is for output. If you look at the labels next to the buttons, they start with an I for input. So we have a bunch of LEDs, a bunch of push buttons, and if we scan up here, we also have some pneumatic actuators. Pneumatic actuators are a type of actuator that can be either on or off. We can extend the actuator or we can retract it, but it's not very easy to get a pneumatic actuator to hold a position between its closed position or its extended position and its retracted position. You'll also notice to the left of these pneumatic actuators these are valves. This is how we extend and retract pneumatic actuators. We do it by turning valves on and off. Each of these valves has two tubes leading from it. One of the tubes is for extending the actuator, and the other tube is for retracting the actuator. So you'll notice that these are also labeled with an O. This actuator also has a switch that can determine whether the actuator is extended or retracted. So you'll notice that the label next to these switches starts with an I because this is an input. Now, the computer is where we're going to actually write our code. On the computer, find the folder that's labeled Dr. Sodeman and open that folder. Here we have some code templates that have been made for us. In this folder, start by finding the file that's called Exciting Demo. We're going to start by just running this code that has already been written for you so that you can see a demonstration of what the different parts on the board can do. Double-click on this file to open it. This will also allow us to learn how to download code to the PLC and run it. Take a look at this code for a moment. You'll notice that this screen looks very different than the kind of code that you are used to writing for the PSOC. The kind of code that you write for the PSOC is the language C, and it's a kind of a language that's called structured text. In contrast, a PLC uses a kind of a language that's called ladder logic. It's called ladder logic because, as you see, it has these wires strung from the left to the right that kind of resembles the rungs on a ladder. This is not a structured text language, and it's a particularly useful language when the kinds of things that you want to do with it are to turn things on and off in response to things like buttons being pressed. In today's lab, we're going to learn some basics of how to write ladder logic code to make things happen with a PLC. The first thing we're going to do here is learn how to download this code to the PLC. This is very similar to how we run code on a PSOC. You know that with the PSOC, after you've written your code, you compile or build the code, and then you download the code to the PSOC. Once your code is downloaded to the PSOC, the code runs on the PSOC so that you could connect the PSOC to a battery disconnected from your computer, and the code would run wherever the PSOC happens to be. This is the same way it works with a PLC. We're going to write our code in ladder logic, and then we're going to download the code to the PLC. The code could then run on the PLC wherever we may wish to connect the PLC in the factory. So to download the code, first take a look at your PLC. There is a switch on the PLC that can be turned, and it can be turned to point at Run, REM, which stands for Remote, or Prog, which stands for Program. Switch the key so that it's pointing to the program, like that. And then back in your code, up here in this drop-down list where it says Offline, click on Download. Click OK to proceed with the download, or click on Yes, and the code will be downloaded. Then it will ask you if you want to go online, and say yes. Now, the code is not running right now because you first have to switch this switch over here to run. Now, the code is written to start when you press this button. So press the button and all of the different kinds of outputs will cycle through their on and off states. If you watch the code while this is running, you will notice that there are these green lines. Let me go back and look at this again. That turn on and off. The green lines are showing you which of the inputs are being actuated and which of the outputs are being actuated, so that you can watch what's happening in your code while the code is running. Now switch this switch back to program to make the program stop running. And the next thing that we're going to do is write some very simple code ourselves to help you see how ladder logic works. Close the exciting demo code and go back into the Dr. Sodeman folder. In the Dr. Sodeman folder, find the file called Robotics template.rss. Double-click it to open it. The first thing you should do is click on File and then click on Save As. For the file name, give it a name that includes your name or the names of your group members, and then click on Save so that you can save this file to access it later on, and so that other people can access this blank file also. So give it your name and then click on Save. This is a blank file that starts out with no code written. We're going to start by writing some simple code of our own to see how ladder logic works. In your code window, right now you have just one single rung in your program. This rung works very similar to a wire. When your code runs, imagine that electricity is going to flow down this wire. On this wire, we can place inputs and outputs. The inputs serve as switches. When the switch is open, the electricity cannot flow through this wire, and so any outputs that we put on the other side of the input will not go on. However, when we press the switch or actuate the input, the output will be actuated because the electricity is allowed to flow through the wire. Let's write some test code to help illustrate how this works. The first thing you need to do is to place a new rung into your code. To do that, let's take a look at the different kinds of things that you can place here up at the top. This first item is a new rung. You can click and drag this item down to your screen to place a new rung into your ladder logic. Before we do that, let's take a look at what are the other things that we could also do with our code. The next button is called a Rung Branch. We'll be using this later on to do ands and ors and if statements in our code. The next item is called Examine If Closed. This is a switch or an input that we can place into our code. The next button is called Examine If Open. This is also an input that is another kind of switch. Next we have the outputs. The first one is called Output Energize. Then we have Output Latch and Output Unlatch. Over on the left-hand side of the screen, you will find all kinds of inputs and outputs that you can assign in your code. This part of the code is similar to the top design part that you have in PSOC Creator. And also it serves the purpose of the pin assignments window. This is where you can tell the PLC which pins, or in terminology of the PLC, which terminals are connected to which inputs and outputs. This part has already been done for you. If you take the Industrial Automation class with Professor Gintz, you will learn how to do this part also, where you assign which inputs and outputs correspond to which terminals. For now, we're going to use the setup that has been created for us. Now, here is what we want our code to do. This will be a very simple starter code. I would like it to be that when we press this button here, this LED over here will go on. Let's write that code now. We need to start by placing a new rung. First, we need to make sure that this rung is highlighted. You might have to click on it. Then, click and drag a new rung. And when you drag the new rung down, you will notice that a little green box appears like this, indicating that you can place a new rung here. When you see this green box appear, let go of the mouse button and that will place a new rung on the screen. And now your code should look like this with 2 rungs. Now we can click here at the beginning of the rung to indicate which rung we want to be using. Click on this first rung to highlight it because we're going to place our code there. Now go up to the top and find an Examine If Closed item and drag it down to the screen. When you drag it down to the first rung, a little green box will appear at the beginning of the rung. When you get that little green box, let go to place the switch on the rung. Right now, this switch input that you have placed has a little question mark at the top. That's because we haven't yet assigned which input corresponds to this switch. Let's right away go assign this input. In the left-hand side of your screen, find the Input item under Data Files and double-click on it. It will open up a window that looks like this. Here we have a matrix of values. Each row corresponds to a number that is the first number in an input. So the first row is input 1 dot something, the second row is input 2 dot something, and so forth. Now let's look over at our buttons. Notice that this first button is labeled as input 1, 1. Look back at this matrix and go to row 1 and then follow it over to the column that also says 1. Input 1 dot 1 is right here. Click and drag this item up to the top of your input. When you get this item dragged to the top of your input, a little green square will appear at the top of the input, indicating that you can drop that input there. When you get the little green square, let go of the mouse button to assign that switch to that input. We've now assigned switch 1, 1 to the input switch which we've placed on our rung. Now you can close this window. Next, we want to place an output. Find Output Energize and click and drag. If you don't get that little green square, go back to the beginning of the rung and click to select the rung. Then try it again. Click and drag Output Energize until you get a little green square and then let go. Now we want to go over to the left-hand side of the screen and find the item called Output. Double-click on the outputs. You'll see that we have a matrix very similar to what we had for the inputs. This matrix works the same way. So the first thing we need to do is go look at our LED output and see what the number is. It's labeled as output 42. In our matrix, we're going to look at the row that's labeled 4 and the column labeled 2, and we're going to click and then drag up to the top of our output until the little square at the top turns green, and then we let go. You'll notice that our 4-2 gets placed here and it's called red light 1. you can close the output window. And now we want to program the PLC with this code. Let's think for a minute about what we just programmed to our PLC. Here we have a switch, and you'll notice that the switch appears to be open right now. If we think of this rung as being a wire, the electricity will not be allowed to flow from the left to the right because it will be stopped by our open switch. Therefore, it will never turn on the red light. But when we close the switch, then it will turn on the red light. So let's download this code to the PLC. The first thing you need to do is go over to the PLC and turn the key to the program position. Now, over in your code, click on the drop down arrow by offline and click on download. Click yes to proceed with the download. Then click yes to go online. Now the code is online, but if we press the button, nothing happens because we haven't yet switched our PLC to run mode. Switch the PLC to run mode and then press the button. The red light should go on when you press the button. Also, we can monitor what's happening with the buttons and the lights in our code. Every time we press the button, this little green line should appear on the switch, indicating that this switch is closed. Then the green light should also appear on the output, indicating that the output has been activated. Try pressing your button a couple of times and watch what happens in the code while you press the button. You may notice that the code that we've just written is the same as an if statement that we could write in structured text. Our code here says, if the switch is closed, then turn on the light. Now, click on the drop down by where it says run and click on go offline. Let's write another program that's a little bit more complicated. In this code, let's make it so that the red light will only go on when we press both of these two buttons. In other words, let's write some code that will not turn on the red light if we press only the first button, or turn on the light if we press only the second button, but it will turn on the red light only if we press both buttons. And let's use the same LED as our output. So if I press both buttons, then I want the LED to go on. How could we do that in our code? First, click on the start of the first rung to make sure that it's selected. Then go to the top and get another one of these switches and drop it onto the rung next to our first switch. Open up the input matrix again, and this time we want to find the input that corresponds to the second button. The second button is labeled input 1, 3. So we're going to go to this matrix to the first row and the column that's labeled 3, and we're going to drag that item up into our second switch. Now click on the offline drop-down list. Make sure that the PLC is switched to program and click on download. Click yes to proceed with the download, and then yes to go online. Now switch the PLC to run mode and test to see what happens. When we press the first button, the LED does not go on. However, we notice that when we press the first button in our code, the green light goes on around the first input, showing that it detects that we have pressed the first button. However, you'll notice that the green light does not go on the second input because we have not pressed the second switch. Therefore, the output also does not go on because we've pressed the first switch, allowing electricity to go through that switch. But the second switch is still open, so the flow of electricity is stopped there. Likewise, if we press only the second button, we can see in the code that that button is activated, but again, the LED does not go on. The LED only goes on when we press the two buttons at the same time, therefore closing both of the switches and allowing the output to be activated. What we've done here is an AND operation. We've programmed the LED to go on only if switch 1 and switch 2 are both pressed. If we were writing this code in structured text, we could do this by nested if statements. We could have one if statement that says if switch 1 is closed, and then we could have a second if statement inside of the first one checking to see if switch 2 is closed. Next, let's see if we can write a program to do an OR statement. In this program, I would like to have the red LED go on if I press the first button or if I press the second button. Switch the PLC to program mode. Then, in this drop-down list, go offline. In order to write an OR statement, we're going to get a second wire in addition to our first rung, and this rung is going to be a rung branch. It's going to be a wire that can bypass the first switch. So find the item that's called a rung branch and click and drag. Make sure the first rung is selected before you do this. Then drag the rung like I did here. Now take the first input and click and drag it. Place it in the top of the branch as I've shown here, and take the second switch and drag it to the bottom of the rung. What we've done here is created an OR statement. Can you see how this code is an OR? If we press switch 1, the electricity will be allowed to flow through that first switch and reach our output. Or if I press switch 2, the electricity will be able to flow through this branch and still reach the output. It will also work if we press both switches, but it will not work if neither one of the two switches is pressed. Let's test this code and see if it works. Click on Download. Click Yes to proceed with the download. Yes to go online. And then switch the PLC to Run. And let's test the code. The red LED should go on if you press the first button or the second button or both, but it should not work if neither one of the switches is pressed. Watch your code to see which switch is being activated and when the output is being activated. So far, we've used push buttons and LED lights. Now, we're going to take a look at what we can do with some of these pneumatic cylinders. To begin with, go up to this drop-down list where it says Run, and let's go offline. Up at the top of the board, you'll see these two cylinders mounted on the board. These are two pneumatic actuators. They can extend or retract. You'll notice that there are two tubes going to each actuator. For each of these actuators, one of the tubes is to make it extend and the other is to make it retract. You'll also notice that underneath the cylinder there are two input values labeled. These two inputs are connected to sensors that can detect whether the cylinder is extended or retracted. If you follow the tubes back, you'll see that they're connected to these valves, and that each of these valves has two numbers on it, and these two numbers are labeled as being outputs. These two numbers tell you which output is for extending the cylinder and which number is for retracting the cylinder. Right here, these two numbers are the ones I'm talking about. Now, go down to your code and go offline. We want to add an output to make the cylinder extend when we press the button. So start by selecting the rung and then try and go get an output. First, place the output on the same rung as the LED. Open the output list. 5-1 and 5-0 are the two numbers that are labeled on the cylinder. You'll notice if you hover over 5-1 and 5-0, these two things are labeled as retract top and extend top. That means that those two outputs are for retracting and extending the top cylinder. Try to drag extend top to this output, and then we're going to try and download this code. When you do this, you'll notice that you get a warning that says program has errors, cannot download. This is because we made a mistake in the way we wrote this code. In this rung, we've placed two outputs in series with each other. In ladder logic, it may seem like this would work. When the switch goes on, this output will go on, which will make this other output go on also. But as it turns out, you can't do this. Instead, in order to make both of these outputs go on when these switches turn on, we need to use the same kind of a trick that we used a moment ago with the inputs. We need to go up to the top and get a branch. Select the rung and then get a rung branch and drag it down onto your rung. We're going to take this one output and place it in the top of the rung, and we're going to take this other output and place it in the bottom of the rung. Let's try this again here. We're going to take the top one, place it, there we go, and then we'll take the other output and place it in the bottom. There we go. So now we have two outputs that are in parallel with each other. Switch to program mode. Then click the drop down and download the code. Go online and then switch to run. Now, when I press either one of these switches, the top cylinder should extend. You'll notice that the cylinder does not retract, regardless of whether you press the button or not, because we haven't yet put an output that tells the cylinder to retract. For now, you can just make the cylinder extend by pressing either one of these switches. Switch the PLC back to program mode. Let's see if we can get the cylinder to retract when we press one of the other buttons. Go offline, and we're going to modify our code so that the cylinder extends when we press one of the buttons and it retracts when we press the other button. Go up here and get a new rung. So you now have 3 rungs. we're going to take one of these buttons and place it on the second rung. Now we're going to take a new output and place it down here. Open up the output list, and now I'm going to get the retract output, either 5.0 or 5.1. Let's take a look here. Five zero is extend and 5.1 is retract. So I'm going to put retract into this output. Now we need to delete this branch. Click to delete the branch, and then we're going to download the code. Switch the PLC to program mode. You should be able to make the cylinder extend when you press the first button and make it retract when you press the second button. We're now going to try writing some code that is a little bit more complicated. This code will introduce you to some new features that you can do on a PLC, like latched outputs. We're also going to see how you can use the results of an output as an input. For this code, we want to start by using this button here, and when we press that button, we want to make this cylinder extend and retract, and then extend and retract again over and over again once we've pressed the button. Now notice that there are these two switches shown here that are labeled as inputs, input 1.7 and input 1.6. These are the two inputs that are turned on and off when the shaft of the cylinder hits these two switches. Also, we can follow the tubes back to find which outputs right here will cause this cylinder to extend and retract. Now let's go to our code and let's clean it up a little bit by deleting the things that we already have here. We're going to start from a blank screen to create our code for this cylinder extending and retracting. Once you've deleted all the parts, select the first rung and go get an input and drag it to the first rung. Then open up the inputs, and we're going to go over here and see which input is the switch. And we'll drag the 1.1 input to this input. We're going to use this input as a way to start our code regardless of whatever state the cylinder might be in. So now go and get an output. Oh, we have to select the rung. Then go get an output. And open up the window to assign this output. And let's look back at what we want to assign it as. We want to extend the bottom cylinder. So find extend the bottom cylinder and drag that to the output. And now we're going to select the second rung and place an input here. Next, let's look back up at the switches that we saw before. We just placed an output that says extend the cylinder. This switch over here will be triggered when the cylinder is fully extended, and that is input 1.6. So we'll go back to our code, to this input that we just placed here, and we're going to get 1/6. We'll assign 1/6 to this input. Then we'll go get another output. Here, we're going to assign this output to retract the bottom cylinder. Now, let's think for a moment about what we think this code is going to do. First of all, if the switch 1 is never closed, then extend the bottom cylinder over here won't happen. But when we press the first switch, the cylinder should extend. When the cylinder is fully extended, the switch down here will close, and so the cylinder should retract. Let's test this code and see what actually happens. We'll press the switch. You'll notice that the behavior is not what we expected. We want to make the cylinder extend and retract over and over again after we've pressed the switch. But that's not the behavior that we observe. Let's try and make a change to our code to see if we can get the cylinder to extend and retract. Let's delete the retract output, and this time we're going to find the output latch element and drag it here instead. The output energize item that we've used before only turns the output on as long as the input that comes before it is true. A latch works a little bit differently. With a latch, once it is turned on, it stays on until it is turned off again. Let's see if this changes the effect of how the cylinder behaves. We'll run the code. Now, when we press the switch, the cylinder extends, and when we let go of the switch, the cylinder retracts. This time, the cylinder retracts all the way. Now, let's go back to our code again. Go offline so that we can make some changes. Add another rung, and then let's add another input to this rung. We're going to see if we can get the cylinder to extend and retract over and over again in series. For this input, we want to use the other switch, the switch that is triggered when the cylinder retracts. Now, we'll get an output unlatch to begin with. When the limit switch on the left is triggered, we want to unlatch the retract, and we want to latch the extend at the same time. So for this unlatch, we're going to unlatch the retract. Now, let's test this code. When I press the switch, the cylinder extends, and when I let go of the switch, the cylinder retracts. But the cylinder never extends again when the left switch is placed. That's because we haven't yet placed the latch to make the cylinder extend. So let's go offline, and this first output up here, let's delete it because that's just an output energize. Let's make it be a latch. Now select your second rung and let's place a branch here. Rather than simply latching the retract, we're going to need to unlatch the extend at the same time. We need to do the same thing on the third rung. Go get a branch so that we can unlatch the retract at the same time that we latch the extend. Get an output latch and drag it into the bottom of this branch. Now let's test the code. Note that the button is now only used to start the code in the case that the code starts with the cylinder neither extended nor retracted. As long as the cylinder starts in one of those two states, the cylinder will continue to extend and retract whether or not we press the button. While your code is running, you can watch the program on the screen to see what turns on and off in what order. Once you get this working, you know everything you need to know to try and solve the final task here. For your final task, we're going to use one of the pieces on the board that haven't been used before, but all of the code that you need to place in your ladder logic you've already learned. Latches, unlatches, output energizes, switches, and operations and OR operations. Here's what you need to accomplish. For this task, take a look at the two cylinders that are over in the upper right-hand corner of the board. Here, there are two cylinders that are attached to each other, one that moves in and out horizontally and another cylinder that moves in and out vertically. I would like you to figure out how to write some code in ladder logic to make this 2 degree of freedom manipulator extend and retract. In other words, I would like you to write some code that makes the horizontal cylinder move out, the vertical cylinder move down, and then moves back to its starting position, with the vertical moving back up and the horizontal moving back in. It should do this over and over again on its own, just like we did with this single cylinder a moment ago. You can use a button to start the code if you would like. But after your code is started, you shouldn't need to press any buttons anymore to make the motion happen. It should simply extend and retract just like this cylinder did in the test code. You can use any combination of ands, ors, branches, any number of rungs that you need, and latch or unlatch or output energize items that you need. Once you get this working, take a picture of your code and also take a video of the two cylinders making this motion and upload it to the section on Blackboard for the Industrial Robotics experience. Also, delete your code on the computer so that the next person to do this lab can start from scratch.